Welcome to Lesson 25, Learn C Programming on the Raspberry Pi. Alright, last time we were talking about all the different operators we have in the C language, and we also went over the concept of precedence, which operators have higher precedence than other ones. So we'll continue with that. Let's first go to the Raspberry Pi. Now, one thing I want to mention is that it's been a little while since Lesson 24, so I made a few changes to the Pi. Nothing major, but one thing I have done is I've added more themes to the Genie editor. I'll show you what I did. If you go to a directory .config/Genie, you do an ls, you'll see that there's a directory called color schemes. And so what I did was, if you look at color schemes, you can see I added in a whole bunch of these conf files. These are different color schemes for the Genie editor, or the integrated development environment. So you can make Genie look like gedit if you like, use the same colors as gedit, or you can make it look like the default Ubuntu colors. Anyway, what I'm using is, I believe I'm using the Oblivion color scheme. So let's fire up Genie and see what we get. Oops. Where am I here? Okay, so you can see the color scheme that I'm using. If I go to View and I change color scheme, you can see that I'm using, I believe I'm using the Oblivion 2. Where is it? Right here. Okay. And there are other ones, like, for example, Notepad, if you prefer that. Anyway, I'm going to stick with Oblivion for the time being, just because it gives nice, pretty colors. And so, looking at what we did last day, I believe we also went our recent files. If you look at our notes, what we did so far, we have a lot of information that we went through. But I've added into the bottom two new items, standards, the ANSI standard and the ASCII standard. And I'll be talking about both of those in today's lesson, and probably in the next lesson as well. So I want to start just by talking about characters. So let's start with a new program here. Create a new file. And what I'm going to do is I'm just going to declare, for example, a character. I'll just call it C, and I'll initialize it to the capital letter A, and then I'll just print it out. Value of C is, and I'll print it out as a character, and then a new line. I'll add a new line at the end. C. And that's my complete program. So I'll save this guy. Save as. I'll save this in Lesson25, and I'll just call it char1.c, character1.c. And what I'll do is I will then build it. What did I do wrong? Oh, should be for a character I should use single quotes. This, if you look at the error, it says a warning with this C equals quote a quote. Double quotes signify a string in C. Single quotes signify a character. So let me make that correction here. Quote. Oops. Okay, so now I've corrected that to a character instead of a string. Save it. I'll try building again. And this time we have compilation finished successfully. So now I can actually run it, execute, and it runs in the terminal. You notice my terminal is quite large here because what I did also before this lesson started, I went to Edit Preferences, and I set up what I wanted my font to be for this terminal, what my background should be, and what my foreground should be. Okay, because the default terminal when I run in Genie is really a tiny little terminal with a black background and white letters, and it's not very easy to see. Anyway, you can see the result of this program here. The value of C is A. That's straightforward. So let's try something else. What I'll do is I will print it out this time as a decimal number. Instead of as a character, I'll print it out as a decimal number. So I'll save it, project or build. I'll build it again, and then I will execute it again. Well, I guess I got to execute it again. I should have closed my terminal the first time. Now you notice what happened this time. Printing it as a decimal number up here resulted in printing it out as 65. So the capital letter A is represented as 65. And if I go to my terminal here, clear the screen, let me make the terminal a little bit bigger here. And I say man ASCII. I want to look at the online manual for the keyword ASCII. I think that stands for American Standard Code for Information Interchange. So way back in the 60s and 70s, when they came up with this, you can see that every character is represented by a number. Let me make this thing a little bit bigger here. I don't know if you can see the whole thing on one page. Probably not. But anyway, if you look at the character A up here in the top right hand, you'll notice that as a decimal number, it's 65. And as a hexadecimal number, it's represented as a 41. That's in base 16. And it's represented as 101 in octal or base 8. Well, we can also print that out in those other forms just by changing it. The value of C is, what I'll do here is that, and then I'll print it out in, first I'll print it out in octal, %O. Then I'll print it out in decimal, and then I'll print it out in hexadecimal, X. So since I'm printing it 3 times, here I'm printing it with the format specifier of O, which means octal. Then I'm printing it as a decimal number, base 10, and then I'm printing it out as a hexadecimal number in base 16. So I'm printing it 3 times, so I need to add in here 3 C's. So the first C here will be printed out in decimal. In fact, I could add another C here, %C, to print it as a character as well, comma C. Excuse me. So let's save this guy, and then we will go and build it again. And it seemed to work correctly, so we'll just go and execute it. And now you can see the numbers we got, 101, 65, 41, and A, correspond exactly with what we had up here. Okay? Exactly what we had up there. Okay. So what do we get from this? Well, what we get is that every character is represented by a number based on this ASCII table. Based on the ASCII table. But if you look at the table, there are some characters that are non-printable. For example, if you go down here to, let's say, horizontal tab. A horizontal tab is a non-printable character, but nevertheless it is a character because we have on the keyboard, we have a tab key. So I could have put in here, and it's represented as the character \T. So I could have put in here, if I wanted to, I could have put in \T, instead of having a space in between, \T, instead of having a space in between these different representations of a character, I could have put a tab, a horizontal tab in between. So let me save that guy, build it again, and we execute it. And you can see now we have a tab character in between these guys. So the tab is a non-printable character. It doesn't show up as anything on the screen. It shows up as a spaces, I guess, or white space. Okay, so far so good. Well, let's try the inverse of this now. Instead of saying character equals A, let me put an integer in there. I'll say int I is equal to 65. And what I'll do is I'll just print that I in different forms. So I'll say the value of I is, and I'll print it the same way I print the C character. So first I print I in octal notation, then I print I in decimal notation, then I print I in hexadecimal notation, and then I print I as a character. And let's see what we get. Save it, build it, and execute. And you can see the result is exactly the same. So what we learn here is that the characters and numbers are basically represented the same way inside the computer. They're all just binary digits, ones and zeros, and how we display them on the screen is up to us. We can display them as characters, we can display them as base 10 numbers, we can display them as base 16 hexadecimal numbers, or base 8 octal numbers. We can display them as characters. And so, okay, well, let's now take a look at let's take a look now at another special character that we can't see, the escape character. If you look at your keyboard, you'll notice usually at the top left-hand corner of your keyboard, you'll see the escape key. And the code for the escape key is in decimal, it's 27 in base 10. In hex, it's 1B, and in octal, it's 33. Okay, so let me do away with this genie for a minute here, and well, I'll also quit this man page and make my window a little bit smaller now. So what I like to do now is I like to bring up some ANSI, not ASCII, but ANSI control codes. So I think I have them here. ANSI, the American National Standards Institute. So they show you, or they basically built or codified a system where we can control the terminal. The terminal is this window I have here, and it can obey different control sequences that we call them escape sequences because they use the escape key, which, remember, we said was octal 33 or hexadecimal 1B. So if you look at what we can do with this, it's interesting because you can make your characters come out really nice. Like, for example, suppose we wanted red characters like this, default red. In bash, I could give this command in bash, like so. So what I'm saying is, in bash I want to echo, and the -E is an option in bash that says I want to interpret escape characters, so, or escape sequences. So this has to come out not as the letter E, but this has to come out as the escape key. See, without this -E, if I didn't put the -E as an option to the echo command, then this would just be printed as the letter E. In fact, I can demonstrate that for you just by taking it out like so, and you see it just shows me that exactly. But if I do it with the -E in, what happens is I end up with red. You see the color red came in as red, R-E-D, red. Now if I wanted to make it, and that's the code here, is left bracket 31M. So anything after that is going to be coded in red or colored in red. Let me see if I can find another one here. How about maybe light green? Let's try light green. See what it comes out as. So I'm just cutting and pasting from this web page. You can go and get this information on this page up here. You can pause this video and you can write it down. So here's light green, and you can see it all comes out as light green. I could put them both on one line. I could say, well, there's green, and then I could also do red on the same line by putting it in here. So I better put the quotation over here. And you see what I get is light green followed by red. Okay. So, okay, let's do this in C. I'll bring up, well, let me bring up Genie again. We'll start a new program once it gets going. And let's see, number sign INCLU bracket TDH, and I'll just say printf. And what I'll do is I'll just printf that escape sequence that I have here, and return URN0 and a brace. And let me save this guy. File, save as, and I'll save him in Lesson25, and I'll just call it red 1. Okay. Okay, so we can go and say, let's build it. And you see it, compilation finished successfully, and we will then execute it and see what we get. And you can see now we got light green and red, but you notice what everything that comes after that is also red. So we should have turned the red color back to normal. So let's try that. I'll add in here after the red, I'll put a /e escape character square bracket 0M. That's the code for turning the color back to normal color. So save that guy, build, and then run it again. And now we get what we expected. We get the default comes out in the regular colors, and the light green comes out in green, and the red comes out in red. Okay, so this is really a nice technique you can use for beautifying your C programs if you are running them in a terminal. That is not graphics mode, but in a terminal mode, in text mode. You can, if you had some menus or something for the user, say type in number 1 or number 2 or number 3, you could colorize them, and your program would be a lot more pleasing to the user. Well, we can go further with these ANSI codes. Let me show you this. We can actually position the cursor to different places as well using cursor movement. And these are still ANSI codes, but see the escape character 033 in octal, and then the line number and the column number followed by the letter H or the small letter F. So we can move the cursor on the screen that way. So let's try this. And what I'll do is I will just add another print. And I want to now have the escape character just like I had here. And then I want the square bracket, left square bracket. And let's say I want to move it to line, let's say line 10, semicolon, and let's say column 30. Line 10, column 30, and then capital H to complete the command. Okay, so cursor to line 10, column 30. Okay, so let's do that. Let's save this guy. We'll build it, and then we will run it or execute it. And you can see what happened is we came down here to line 10 and column 30. That's the beginning, that's the 10th line and the 30th column over. So, and by the way, the top left hand corner up here, the top left hand corner is line 1, column 1. Line 1, column 1. Okay. Well, okay, so now using these what's called ANSI, ANSI escape sequences, we can actually position the cursor anywhere we want on the screen, and then we can also colorize our output so that it looks very pleasing to the user. But remember, we are still working with 8-bit ANSI standard, ASCII standard codes. Okay, like for example, this \E is 8 bits. It's the escape character. Okay. Okay. So for homework, I guess what you could do is perhaps you could install some themes, color schemes for your Genie editor. A lot of different schemes. You can download them from the web. Remember, they're just those CONF files, and put them in your Raspberry Pi account. So you can do that, and then you can also then play with these programs to colorize your presentations to the user. You can mix and match characters and integers. And then you can position the cursor wherever you like. So that's it for now, and I'll sign off, and I will see you later for lesson 26.